These are notes for section 5.3, solving linear systems by elimination. Now, we've already had day one of solving linear systems by elimination, and we start with where we left off, making sure that our variables are lined up. So that doesn't change here. What does change, though, is that we need to make one of the variables the same number. Now, on the previous section, all of the problems had one of the variables be the same. But if we take a quick look here at the problems on number 7, I have a 1x and a negative 3. I have a 2y and a 3y, not the same. I have a 6x and a 7. I have a negative 2y and a 1, not the same. I have a 4 and a 2, or a negative 2, and a 4 and a 1, not the same. So what I need to do in order to make one of the variables the same is I have to do some multiplying, and pardon my handwriting, but we got to do some multiplying to the equation or equations to make them the same. So let's take a look here first at number 7. Again, in front of this x, I have a 1 and I have a negative 3. Well, I can multiply this 1 in front of that x in order to make it a 3 or negative 3. Now, I can't multiply a 2 in order to make it a 3 for the y's, but I could multiply both of them, and we'll do some of those on the next slide, I hope, or the next section. But on number 7, I'm going to multiply this top equation by 3 in order to make these x's the same. So I'm going to take this 3 and multiply it by each of the numbers in the equation. That would leave me with 3x, 3 times 1, plus 6y, 3 times 2, equal 39. So all I did was I take my top equation, I multiplied it by 3, and I did that to get my x's to be the same number, or 3 and negative 3. I can deal with the sign whether I add or subtract. Now, to eliminate the x's, since they're the same, I have to figure out if I'm adding or subtracting these equations. Well, again, if I subtract these, negative 3 minus 3, that's negative 3 minus 3. Well, that doesn't give me 0. That gives me negative 6. So I am not subtracting. What I need to do is add, because negative 3 plus 3, negative 3 plus 3, negative 3 plus 3 would be 0. 3 plus 6 is 9. 15 plus 39 is 54. The x's have been eliminated because I added my two equations. Now, to get rid of a times 9, I can divide. That's y equals 6. That's only half the answer. My answer is an ordered pair, something comma 6, something comma y, x comma y. So now to find the x value, I take 6 that I just solved for, and I have to do some substitution, either in there, or either in there. It doesn't matter which equation you pick. I'm going to pick the easiest one, which would be the top. X plus 2 times y, or 2 times 6, equal 13. X plus 12 equal 13. X equal 1. 1 comma 6 is the ordered pair where those two lines cross. Again, this is elimination day 2, where we have a little bit of work to do before we add or subtract our equations. For example, on number 8, x's are lined up, y's are lined up, but neither of those variables are the same. I can't multiply a 6 and make it a 7, but I can multiply a 1 and make it into a 2. So I multiply the bottom equation by 2. So this bottom equation turns into 14x plus 2y equal negative 24. That's distribute. Now, for the sake of having my work nice and clean and next to each other, I'm simply going to copy down this top equation. Not necessary, but I like my work to be right next to each other. It makes it easy to see. Now that my y's are lined up and they're the same value, or at least positive negative 2, I need to figure out if I'm adding or subtracting these two equations. So 2 plus negative 2, 2 plus negative 2 would make those y's go away. So I am adding. 14 plus negative 6 is 8x. 2 plus negative 2 is 0. Negative 24 plus 16 is negative 8. Now from here, I can simply solve by dividing by 8. My ordered pair is -1, comma, something. And again, I have to go solve for the other half of my answer. And to do that, I have substitution. I could take this -1 and I could plug it in here, 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 or here. It doesn't matter which one. Any of those x's will work. I'm going to pick this middle equation because y has a 1 in front of it. So that's 7 times -1 plus y equal -12. That's -7 plus y equal -12. That's y equal -5. The ordered pair -1, comma, -5 is where those two lines cross. One more. Again on number 9. Variables are lined up, 4 and -2, x. My y's are lined up, 4y and y. But neither of my variables are the same. But I could make this 2 into a 4, or I could make this 1 into a 4. It doesn't matter which one you pick. You have to eliminate one of the two variables. So I'm going to multiply by the smaller number. I think it'll make my math easier to work with. So if I take this -2 and multiply it through, that's -4x plus 2y equal 8. I'm going to take my top equation and copy it down. 4x plus 4y equal 4. From here, now that my x's are the same, I'm going to add these equations, and it's not that we always add, it just happens that we add on these three examples. I'm adding because -4 plus 4 is 0. 2y plus 4y is 6y, and 8 plus 4 is 12. To get rid of a times 6, I can divide. That's y equal 2. Again, that's only half of my answer. I'm looking for the ordered pair in x, comma, y. In order to find that x, I do some substitution. Take this y value of 2, and I'm going to plug it in to this bottom equation. -2x plus y equal 4. Nope. Nope, 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 nope. -2x plus 2 equal 4 because y is equal to 2. So that's -2x equal 2. To get rid of a plus 2, I can subtract. And to get rid of a times 2, -2, I can divide. The ordered pair where those two lines cross is -1, comma, 2. Hopefully that helps. I'll see you on the next one. Thanks.